Hello there. Welcome to space. We are Seven Oaks Jammed. I am Jason.
I'm Arnav.
I am Max.
I'm Dehong.
We are going to talk about the concept of states of matter related to space. In chemistry classes, we often hear about solids, liquids, and gases, but there is actually a fourth state of matter called plasma. And plasma is what space is most filled with. It is thought that 99.9% of all visible matter is made of plasma. The sun is made of plasma. The stars are shining spheres of plasma. The beautiful aurora borealis and the lightning that strikes during thunderstorms are also plasma. Only on Earth or some planets can you find substances being made of solids, liquids, and gases, which only account for 0.1%.
We can see the four fundamental states of matter. In solids, particles are closely packed together in fixed positions, held by forces of attraction. They are arranged in a regular way. In liquids, there are weak forces of attraction between particles, and they can move in random motion between each other. In gases, particles are randomly arranged and they can move independently. They can fill the space they are given. Plasma is a gas made up of charged particles such as ions and electrons. They have no defined shape or volume. They can conduct electricity and respond to magnetic fields. These matters can change between each other, as shown in the picture at the bottom right of the screen.
Why are states of matter important in understanding space?
Because it can help us understand how things will behave in space and how they may affect us.
Understanding states of matters in space are also important in developing space travel, which may shorten our time to reach certain planets. Space travel is important as we can colonize new planets, and it is important as we can expand Earth's resources. For example, scientists have shown that Mars has a characteristics and a history similar to Earth's, suggesting one day perhaps humans can colonize it.
Let me expand on how states of matter can help us understand different phenomena found in space. First, star formation. Stars form a nebulae, which are molecular clouds full of superdense gas and dust. They are very, very cold, and because of that, the gases will become molecular, meaning their atoms will bind together. Eventually, the density will become high enough to form stars. You can see the life cycle here on the slide. Phenomenon 2, the black holes. Black holes are made during supernova explosions when stars die. The star's remains are squashed and compressed into a small dense mass. This is the black hole. The black hole takes up everything around it, including gas, dust, and stars to gain mass. Nothing is able to evade its gravitational force. Finally, Bose-Einstein Condensates. It is a state of matter that forms when a gas of low-density bosons is cooled to temperatures near absolute zero. A high fraction of bosons occupy the lowest quantum state under these conditions, at which point you can see that with your eyes.
That's very interesting to learn about all these phenomena. But do you know we can also build things in space? There's a career path called space architecture. Space architecture began in the early 1980s with a small group of architects and designers working on the International Space Station. Today, a growing international community of architects are involved in many projects around the space field, for example, the robotic rover or the space probe design. This shows a huge volume of work, but what background do you need to become a space architect? First, you need professional degrees in architecture or industrial design. Furthermore, you need to have become familiar with all topics related to human space exploration. This will be our future.
Thank you for listening. I am sure you are more ready for your future space adventure.